Welcome back to the lab. I wanted to take a moment and say thank you for everyone that has subscribed. YouTube sent me an email telling me we ticked over 100 subscribers between this video and the last one. Everyone here is why this channel exists. If there's anything you'd like to see, drop me a line, leave me a comment, and we'll see what we can work into the recording schedule. Thanks again for your input, and being here is greatly appreciated. And we'll get started with this guy. Okay, on the bench today is a AA501A distortion analyzer. It's in it. This is a TM500 unit. This did come from the ether of the internet. I'm really glad it made it in as good a shape as it did. The post office and the shipping did not treat this unit kindly. The box was very destroyed. So I don't know if we're going to have any problems with it. Get it rattled, if anything's been knocked loose or rattled loose. But we'll see what's going on. This is the updated A version to my TM501. So they're pretty close to the same unit. The thing that caught my eye on this one was this button right here. This is a intermodulation measurement, which means from the front panel, this one could either have option 1 or option 2. Turns out this one has actually option 1 because this says A weight. There's a different filter here if it's an option 2 unit, but the main difference between the two is a little bit updated on here. This is the older unit, and this one can do the intermodulation measurement. This is going to partner with this plug-in, which is a SG505. This is a incredibly ultra-low distortion signal source. This particular one, of course I forget what the option is, option 1, has option 1, which has the intermodulated test signal. So that'll do a double tone. You can put a carrier frequency out with a modulated frequency on top. And this, because this has the intermodulation measurement, is capable of splitting that back apart and doing a measurement with it. My other SG505, this is the option 2 version. 2 version has intermodulation as well, but it has fully balanced outputs. So it's a little different. But these two units, so one of the signal sources plus the distortion analyzer makes a audio distortion analyzer for audio amplifiers. So let me know if anybody wants me to go in depth on these. Today, we're going to take a look at the new AA501A and see about getting that one up and running. So on this particular unit, the power frame is a TM502A. Don't necessarily like this power frame, actually. This one's going to need some help. This one doesn't have any feet or anything like that. This unit's going to sweat, but we'll fire it up. I've got everything hooked up to the Variac and current limited supply. So go ahead and kick this on, and we'll just do a smoke test. I'm watching the current. At the moment, it's not drawing anything because I don't have it turned on. And drawing about 15 watts. That's well in spec. The unit does look like it has some life in it. Can probably get the noise down if I actually terminate if I short the output. Let's see. This unit does not seem like it had much use, so The distortion measurement is probably way off because it's picking up common mode stuff because I have it plugged into the isolation transformer. So we're at 13% total harmonic distortion. I bet you we clean this up if we ground the unit. So let me give it a ground. So how the bench works, this is my power strip that's isolated. These power strips are line power, wired correctly off the power transformer, or the isolation transformer. So turn this back on. And there we go. So just having the unit floating, we were getting about 10% THD. Which is it's trying to find out what signal to lock onto. It doesn't know what to do because it's not getting any AC at the moment. So yeah, we're still only drawing about 32 watts. So let me get it pulled out and we'll take a look inside, see what's going on, and if there's nothing wrong with it, we'll just give it a once through, clean up the service, the switches and everything, and then give it a calibration. Okay, the 284 looked really good from the outside. What are we going to find on the inside? A little bit of dust, not too bad. Oh, the side panels hold latches are off. It should have these latches in there, so that'll be something we have to look at. I don't know if I can source those or not. Any other? Move this power supply that's now horribly back heavy. Let's see. That's actually really clean in there. That looks nice. Ooh. That's got to be the intermod board. That is a lot different than my other one. No, that's the DMM board. Okay, that's the DMM board. There's some cow pots down at the bottom. We have some others up at the top. Here's some adjustment locations here, 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 and here. Any down at the bottom? No, none on the bottom. So I am not seeing anything that jumps out at me as the caps look good. Switches need a little bit. They're not awful though. They're kind of crunchy. Oh, ooh. Yeah, kind of crunchy. Let's see if we have a date code. When was this made? 88, 89? Yeah, I'm seeing 86 chips. 87. Most recent chip seems to be 89. So these guys are 89. Don't know what's supposed to go in there. It's missing something. But I don't know if that's a problem yet or not. Here's some more adjustments on this side of the board. Yeah, this unit's even pretty clean. This is in incredibly good shape for as old as it is. Just kind of doing a visual inspection, seeing if any parts got too hot, roasted, blown up, split in half. I'm not seeing much. Let me get this top cover off, and then we'll take a look at the boards on the inside. I'll leave the bottom on, but we'll take the top off and take a look. Okay, here's the view that I just had. So this is pretty tightly packed in here. There is a lot going on. So we even have shielding that slides in. This board, this right here is shielding that slides in between this board right here where all those tantalum caps are. Probably a little bit of insurance just in case they went bang. And also probably some shielding, since noise in this particular instrument is pretty critical. But just looking around, I'm seeing a lot of precision parts, but not a lot of issues. Those, I'm going to get some light down there, but all those tantalum caps look good. Everything looks good. I'm not even having any problems with any of the electrodes. They all look good. So I'm going to look at the board really close to see if there's anything leaking. I wanted to see if there was any electrolytics in here that would cause me some problems. I did need to get in here because with this ribbon cable servicing the switches, I'm going to have to do it through the bottom of the unit because of this ribbon cable's in the way. But we'll get all the switches cleaned up, exercised and running, and then we'll fire it up and see what kind of alignment it needs. Okay, I've got all the switches cleaned up. Everything it feels better now when I push the switches. They don't feel crunchy anymore. So everything is good there. I'm still using this small power pack. We'll see what happens. Do differential input. I got my SG505 outputting 100 hertz sine wave at 0 dBm, which is about 1.5 volt, according to my meter. So we'll set this to volts, level, RMS response, front inputs, and let's turn this on and see what happens. Oh, that shouldn't be doing that with this on auto. That doesn't look healthy. Let's set a range. I know my signal is 1.5, so let's set to 6. Okay, 1.5, and it is telling me to decrease the range, so that's healthy. It's a 1.5 volt signal. So that right there is about what it should be doing. But it's not. Let me turn on some of the filters and see if that helps. So we'll turn on the 80 kilohertz low pass and the 30 we'll turn on the 30 kilohertz low pass and see if that helps stabilize it a little bit. It does. It's still not sure what it wants to do, and it just dropped out. So the signal's coming and going, and it's acting kind of squirrely. I may pop this open. I may clean this control. I didn't clean this one. I cleaned all the other buttons. I may get in there and clean this selector switch, because this is acting... I can't make it come and go wiggling that, so... This one's a bit odd, but at least we got something to troubleshoot, so we get to have some fun. Because that should be stable, and it's not. Now, if I turn on the 400 hertz high pass, it's going to fall out as expected because it's a 60 hertz signal, so it shouldn't be seeing anything through that high pass filter. Okay, so the filters are quasi-working. How about we kick this over here? Let's do THD and auto. Oh, yeah. 30 kilohertz low pass for the THD. Yeah, it's still kind of sick. It's not completely happy. It should be 0 dBm if it was working correctly, so it is not. Okay, well, that's unhealthy. let me get the, let me pull some covers off, and we will start troubleshooting. See where it goes. Down the rabbit hole once again. Okay, I got to spend some time with a little bit of the schematic, because I have that same 0 dBm signal, so I'm expecting about 1.5 volts. I'm reading 0.2, but if I kick it up a range, I have 1.4. So I got to figure out what's actually switching on this when I'm adjusting the range. The auto ranging is better. It's trying to lock in, but it's not doing what it's supposed to just yet. So we definitely have some health issues still. So let me figure out what's switching in for the range and see what we can do. But we actually do have something to troubleshoot. When I know something, I'll bring you guys back. Okay, so I made a bit of progress. Haven't found the fault yet, but I've at least got a direction to go now. I'm not just flying blind. So this was my chip of interest. Nothing was working except in the 6-volt range. For some reason, the 6-volt range is working fine. Here's my truth table for U7011. This is U7011. At the 6-volt setting, I get good outputs. I get nothing else. So, first step, the rest of this unit can't work because this is my input amp gain control. This is the control for the AGC, the automatic gain control. And it's either not being fed or not outputting correctly. I'm leaning to not being fed. So I'm going to shift back in the circuit a little bit further, see what feeds you 7011, and see if that IC is having problems. But I definitely have a logic problem in this unit, so I am not exactly sure what happened to this thing, but it is sicker than switches. So when I know something, I'll bring you guys back. Okay, just for grins, I turned on the AC calibrator to generate some high voltage AC, and we're locked in at 100 volts AC. So this is actually 100 volts at 1 kilohertz. So this is not line power. This is high frequency AC. So we do have some signs of life. We're not that far off. 0.2 volts on 100, and I can dial it around. Like, I'll turn the calibrator off. We'll drop it to 70, and boom. So a little bit out of cal, but that should be easily fixable. We definitely have a logic problem in here. So let me look at that driver for that chip, and I will get back to you guys when I know something interesting. But this is a good sign. It means the meter portion's working. Let's, this thing's supposed to have decent distortion. The 5200 is supposed to have decent distortion specs. Survey says I'd agree with that. This is that weird pulsing that I've mentioned in some of my videos. You can see it over here, kind of pulsing in the background. That's a chirping noise. I have yet to figure out what that is. It shows up in my spectrum analyzer. It'll show up on an audio generator. I think it's beacon time of my Wi-Fi. It's a harmonic of my wireless, but you can see it's periodic. It's just chirp, 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 chirp. So if anybody has any idea what that might be and how I might be able to get rid of it and get the lab a little quieter, that'd be great, because I've been hunting that down a little bit. If anybody's even curious as to what that is, I'll set up the spectrum analyzer, and it's broad spectrum noise. If I hook up an antenna to my spectrum analyzer, it drives my spectrum analyzer nuts. So we have signs of life. That's good. Now I just got to get the auto ranging functions working, and we'll go from there. Sweet. Okay, I have the logic analyzer set up on the Rigel. I'm on U7011, and I'm checking the outputs, Q1, Q2, and Q3. So it's Q1, Q2, Q3, and enable. So if I have everything set up, I have it on auto now. Turn this on, and we see D0 is bouncing. But if I turn this on to the 200 volt position, our enable went high, which was good. And at 200 volts, we should, on our truth table, we should see 0, 0, 0. So we have 0 bits and 1 high. That's okay. At 60 volts, we should have 1, 0, 0. And we don't. It came in and then fell out. So this should be 1, 0, 0. And it's not. At 20 volts, it should be 0, 1, 0. It's not. At 6 volts, it should be 1, 1, 1. And it's not. At 2 volts, it should be 0, 0, 1. Oh, look. 0, 0, 1 with our enable. So we have it. And 2 volts was one of the ranges that was working. 600 millivolts. Should be 1, 0, 1. Nothing. 0, 1 with enable. That's bad. 200 millivolts. Yeah, D0 shouldn't even be oscillating like that. This is it should be, yeah, we are on 20 millivolts. So on, or sorry, 200 millivolts. On 200 millivolts, we should have 0, 1, 1. You shouldn't see anything here. It should be 0 and then 1, 1. It's not. I'm pretty sure that IC is dead. So I'm going to order up some replacements for U7011, and we'll go from there. Because this the truth table is nowhere close. So that IC is toasted, but because it's right at 200, because I'm expecting a 0, 0, 0, and that's what we get, that is working as expected. And because Q3 is functioning as expected, that's why 2 volts works. Because Q1 and Q2, it looks like Q1 and Q2 are fried. And this is really what it comes down to. Which is why 200 works, which is why 2 volts works, and everything else is kind of out to lunch. Now, let me print off a bit of the schematic, and I'll show you what this thing's actually doing. Okay, here's our IC of interest. Where I had the logic analyzer probes hooked up was Q1, Q2, and Q3. This is U7100, all of this. I was also watching pin 1, which was the PE that's open when you're on auto, so it disables this chip and lets everything else run. But the Q1 was the one that was oscillating. It was just flicking up and down. So Q1 and Q2 were not outputting correctly given P2, 3, and 1, 2, and 3's inputs. So I wasn't watching the inputs, I was watching the outputs. And as you can see, we just have 12 volts feeding through a resistor into the one, and then we're switching in ground when we want to ground out the pin to get the truth table. So there's not much to it, and I've checked the switch. The switch is working normally. So because this drive is dead, I'm going to start there. We'll replace 7011, and we will see if we have to go further, because 7011 drives 301 and a few others, but we're into a little bit of logic debugging. But we'll start with that IC. I have to order them, so through the magic of the camera, I will be back when the mail gets delivered. Okay, I have our new IC in. Everything is going well there. Let's see if we power up the unit, if we get any smoke, or if we get our meter back. Okay. See if we get magic smoke. No. Well, that's good. That's not. We still have our galloping ranges. So, let's see if we made any improvement or if our ranges are still busted. I've got the calibrator set to 100 volts. I was cautiously optimistic hooking the calibrator up. Well, that's an improvement. There's 200 volts. Let's see how we do with 60. Set this to 45. We'll drop this down. A little bit better, but it still doesn't know what it wants to do. Let me dial this up. 65? Oh, wait. Okay, it's changing when I change the calibrator, so it's measuring something. Let's try 15, and we'll go to 20 volts. Okay, that doesn't work at all. So that's toasted. How about 6? Because 6 was having a problem before. We will set this to 5 volts. Okay, 6 is back. All right, so we have definitely made improvements. How about 2? We'll go down to 1.5. Yeah, 2's back. Okay, so we have definitely made improvements to the unit, but it's not healthy yet. So, where's my schematic? Okay, here's U7011. This is the IC that I replaced this morning. I was waiting on these. I'm going to immediately go over to U3011. I'm going to hook up the logic analyzer again on the outputs of here and see if we're getting the correct outputs, because this is directly telling the amplifier circuit what dB to apply to the incoming signal, both positive or negative. So my next culprit, since we now know this IC is good, is this IC is suspect. So let me hook up the logic analyzer and we'll see what that tells us. Okay, we're hooked back up to life support. I have truth table, a bunch of extra cables, and we have the schematic. Schematic actually does have what's marked as what pins should do what. So let's see if we turn this on and I play with the U3011 was actually very easy to get to. It's this guy right here. So that's 70, 7011, 3011. So that's good. So let's see what the logic analyzer says. Okay, so I've mapped logic analyzer to settings and what pins they should be on. So I'm going to move over to the logic analyzer. I'm going to move the range knob, and we'll see at least if U3011 is working. Okay, I have the logic analyzer hooked up. It's on auto range right now, and it's blinking back and forth, so it's not exactly the happiest thing on the planet. So we'll go to 200. This should be negative 40 dB, so D2 should go high. And it does. There's D2. Next one should be D5. It did. Next one should be D1. It did. D6. It did. D0. What was that? That was interesting. I'm glad the camera caught that. Next is going to be the 600 millivolt range, which is going to be D3. It did. And the next one's going to be plus 20 dB, which is going to be D4, and D4 should stay high for the rest of it. Okay, I'm going to turn this off. And I'm going to see if I can't get it to do that again, because that was odd on the 2 volt range, 0 dB. No, that did okay. Now it's trying to range. It doesn't know what to lock into. Now let's see if we can't give it 1.5 volts and see what happens. Turn this off while I hook up the source. All right, there we go. Okay, we have it set to auto. I'm about to give it 2 volts. It's not reading correctly because it's reading 1.3 when I'm feeding in 1.5, but it is working, so that is not our problem. That IC is working correctly. Okay, let me think, and if anything interesting happens, I'll bring you guys back. Okay, so I've tested all the digital circuitry, and that all seems to be at least up into the outputs of that inverter. Everything seems to be functioning normally and is healthy. However, this is watching the output of the function, the input monitor output. So I got to figure out where this is coming, and I got to figure out where the signal is becoming like that. I can get it to lock in on some frequencies, like if I turn this to 60 volts, and then, because you can still see just a little bit of the frequency in there, if I bump this up to 50 volts, still not that stable, still not that great. If I go to 200, locks in right like it's supposed to. So 200's behaving, 60 not so much. So if I go back to 60, I have the, I don't have any of the filters on. 30 kilohertz low pass. We'll give it 60 hertz. So 50 volts at line power. There we go. That looks pretty healthy. And nada. So now my question is my notch filter working? Or is my, because if let's adjust the frequency, see if it's frequency dependent. All right, 50 volts at 5 kilohertz. Turn that off. This is the 20 volt setting. No filters. So this is 10 volts at 5 kilohertz. Nothing, won't pick it up at all. 3 volts at 5 kilohertz at 6. Locks in exactly like it should, and it's reading 2.9. So, I have a sneaking suspicion we are out of the digital and into the analog. I'm going to need to think about this one for a little bit, but the input monitor gives me some clues. Let me see where that's coming from in the circuit. That may give me some clues as to what exactly is going on. Okay, I've spent a little bit of time with the schematic, and I want to measure at the front end of this op amp right here, which is 4061, which is this guy right here. I'd like to see what's going on the inputs, because that'll help me validate this network and these two op amps. I'm kind of worried about these two op amps because my input monitor comes from pretty much right after this stage. So somewhere I'm picking up noise, and I'm hoping it's not these two, because these are one op amp, but these are a special, unavailable op amp. So if this ends up being the problem, that's going to be interesting to source parts. Should be able to source some parts, but so what I'm going to do is I'm going to feed some signal in the front, because my front end connectors are right here. This is the attenuation network after the digital section. And then that feeds these two op amps, which both feed 4061. So I'm going to look at the output of 4061. If my output's clean on 4061, everything from here over is working correctly. If it's not, I'm going to have to go back one more, and hopefully it's not these guys. But given that the input is not stable, and it's also floating up and down, I have a sneaking suspicion, given the way it was behaving on the scope, and especially when it was on 20, it was shoved all the way to the negative. I have a sneaking suspicion that a couple of one or more of these op amps is having trouble. So it's a matter of just finding out which one, getting it replaced. But let's see what's happening right here. Okay, well, the plot thickens even more. So here's pin 6. Let me turn up this scope. This scope is the input monitor. This scope is the output of the op amp. There's pin 6, and everything looks kind of healthy. And everything flies to the rail. We'll go down one. And they're both noisy at the same time. So that means my input monitor is following my output monitor. So my everything post pin 6 is working, because it's garbage in, garbage out. See there, it just stabilized. So now it's stabilized. Back this off one. There. So it's locked in now. So everything is good. Everything is working. The chirping you're hearing is that incessant chirping that I had. See there, it just went nuts again. So it doesn't know what it wants to do. Do I have bad relays? Do I have a bad transistor block? Or do I have a bad op amp? Because there's not much left. And at this point, I would much rather source the op amp than I would source the read relays. So I'm really hoping it's the op amp. So when it locks in real well. But it's definitely struggling locking in. And it is coming from the input. Let me bring you guys back to the schematic so I can kind of show you what I'm seeing. Okay, so we know we have garbage at this point, and that's what I was measuring right there. Now the input monitor is coming from further in the instrument, but the noise at this point matches the noise at the input monitor, and when that gets slammed to the rail, so does the input monitor. So the input monitor circuitry is probably working. The problem is that leaves this op amp this rectifying circuit and these reed relays in the attenuator network. I'm gonna pull the signal off, and I'm just gonna move the control a whole bunch. See if it is the reed relays. See if this is just lack of use, because this thing is in pristine condition. I don't know if it's been used that much. The contacts could just need to scrape together a little bit and clean up. So let me run through the range selector switch a few times, get the reed relays clicking, and see if that doesn't free anything up. But I'm either thinking these transistors are probably going to be okay, and the other thing with these transistors is they wouldn't act up on different ranges. They'd act up the same way no matter what the range was. The same thing for these op amps. These are acting the same way no matter what the range is, and when it's good, it's good. So I'm kind of thinking these op amps are okay, kind of thinking this block's okay. I'm kind of thinking these reed relays are not in good shape, but I don't know how we'll fix that. So we'll go from there. Okay, so after chasing my tail for a while, I have finally found a bad part. We have a bad reed relay. So what I'm doing is I'm feeding a square wave into the reed relay, and I have it hooked up to continuity for the meter. I have the red side unplugged, but I'll plug that in right now. As you guys can hear, the square wave is switching the relay, so it's actually working. One of the main problems is my square wave is 7.44 volts peak to peak, and at 5 volts peak to peak, which is what the IC is putting out, it's not even driving the relay. So that's a problem. But there's another interesting problem. I'm going to move the microphone back over to the meter so you guys can hear it. I'm just going to touch the reed relay and listen to what happens to the meter. All right, I'm going to touch the reed relay. Just touching the reed relay is enough to make it go crazy. So, unfortunately, that is... Let me stop that. That's annoying. All right. Unfortunately, that is a showstopper at the moment. I'm not going to give up on this unit. I really like this unit, and I do want it to work. However, I'm going to need some more of those reed relays. So this is my faulted out part. This one's actually been changed in the unit before. I could tell because these tails were way too long. So somebody's been in here and has changed this relay before. So I don't know what environment this was in or where this unit was prior to me getting it, but the 60 and the 20 and 60 volt ranges were not treated kindly. So that's where we're at right now. I will see what I can do about sourcing some parts and see if we can't get this meter up and get this distortion analyzer up and running. So if anything interesting happens, I will be back. Okay. Run through a couple iterations of some prototypes, and I'm just doing some final fitment before I send this off to a fab for production. Just making sure my boards would fit, because I am very, very tightly space constrained here. So here are the 5 relays that need to be replaced. This is a block of 4, and then there's one on the other side. These are very critical ceramic relays for the meter. These are the voltage divider relays, so very, very fragile and not easily moved. So I had to work with the space I was given. I did find some relays that were smaller. They're about the same size, minus the legs. So reed relays, they're good for 250 volts DC, so they should be fine for AC. But yeah, that's where we're at. I just cut along my cut lines. There is not a lot of room to work on this, but drew this up in KiCad, cut along my fab cut lines, and I will send this off to a fab house. Obviously, I'll have to wait. So I've got the relays coming. got the board layout done, so we're going to try to bring it back. If this one doesn't come back, it's not for lack of trying. But when everything comes in, I'll bring you guys back. Okay, I have the new relays in. I haven't tested this yet, so we'll see what happens. I have the frequency calibrator, the AC frequency standard coming up. We are set to 15 volts at 1 kilohertz. And okay, that's on standby. All right, let's see if auto range works. This is on auto range. We're on DC level. We'll turn on 30 kilohertz low pass because I have the unit open. It's going to be super noisy. And we'll audio weight because our target's 1K. Flip this on. It's not galloping. So looks like our relay fix may have worked. It's reading about 20 millivolts just on the wire. See what happens if I hit 15, if I give it 15 volts at 1K. Boom, 15 volts. Okay, well, our calibration's off by about a half a volt, but that shouldn't be, that's not a problem. So everything is working. Let's see if ranges are working. 200, it's telling me to decrease range. 60, still telling me to decrease range, but it's still reading correctly. 20. Let's feed it 1.5 volts, and we'll go down to 6. Yeah, perfect. 2. We're good. Stand by. I'm going to turn this down to 10 millivolts, so we're going to feed 10 millivolts in. Lock it in. Okay, wow, that's good. Tell me to decrease to 6. Yeah. Yeah. I'm even, oh, this is wonderful. Stand by. We'll feed it a millivolt. Yeah, even my lowest range is working correctly. I'm not going to test the 200 microvolt scale because with it being open, there'd be way too much noise. But even 1 millivolt is coming through, and it's locking in and notching out. So perfect, 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 perfect. Oh, I couldn't be happier. Let me get everything unhooked, and then I'll show you guys what I did. Okay, so we know from testing that this relay, this read relay, was having some problems, and a high number of these read relays were having some problems. So I sourced another relay, which is a Kodo 2332. Very important for the model number because there's a lot of Kodo relays that are, they have different pinouts and different internally connected pins. So it has to be the 2332 for this to work. And using KiCad, I doodled up these boards, and Oshpark dutifully turned those boards into this. Now, the thing with KiCad is I used a nightly build with KiCad, and Oshpark didn't understand the silkscreen file, so these boards are, that's why there's no printing on here. There's some silkscreen in my layout, but it didn't make it onto the board. The important part was drill holes and the traces. So if I flip it over, this is what it looks like. You can snap it apart. This is the one relay on the side. This is the block of 4 that's sitting internal to the unit. So there's the ceramic resistors are a bridge with some capacitors. There's a block of 4 relays, and there's one off to the side. If I was going to replace them, I figured I'd replace all of them. So that's these relays. Now, it just so happens that a 0.258 millimeter header fits the pinouts for the relays exactly. Same thing on the bottom. It's a standard 2 pins. So this is a bank of 16 with 2, 2, 2, and 2. This is a bank of 4 with 2, and they're straight through with the power pins, 5 volts, being on the outside. Now these Kodo relays, they have a higher coil resistance, so they take less power to actuate than the original part. So it's actually easier on the IC to engage the relay, which is good. And then the 2332 has just straight through, but the coil pins are here and here. The straight through pins are outer and outer. And then there's a pin here, but this pin has no connection. This is actually the key pin, and it doesn't show up. So if you do end up using these boards, I'll see what I can do about a place to post these. I'm not quite sure where I'll do that yet. Or if anybody's interested, let me know, and I can email you send the files. Layout is this way. So outer is 2 power pins, and it's just straight through when the relay's closed. The Kodo relays, the problem is we're also dealing with quite a bit of size issues, because the relays have to fit. There's a lot of room in there, but the relays this way, we have some specific issues. That red block is where, and then there's the 4. So there's the 4 Kodo relays, and there's the other one. What you're looking for is this red block right here. That you can't see it. This red block right here. This is the actual relay. So that's the Kodo relay. That's the interface mezzanine board. And then there's the other board hiding back there. But that's what it brought it back to life. I knew I was going to fit because I printed this out, cut it on the board cutout lines, and this fit in exactly like it fit in and the holes lined up. This is how I check the hole patterns. So there you go. He's functioning again. I need to put the frame back on it, and we have to give it a calibration. But the distortion analyzer is up and running. I'm going to save the calibration for another video because I actually have to get yet another frequency generator. I looked at the calibration document, and I need an FG501. Reason I need an FG501 is because I need a burst of signal to do one of the calibration steps. I already have the 2 SG505s I need, but given that this is an option 1, which has the inner mod, I will get that done. The other thing it calls for is a Fluke 5200A and the associated 5205A amplifier, which we have. They're hiding down there on the bench. So everything we need we've got except for that FG. Wait a minute. It is a 501. I might have what I need. So if I do, I will start the calibration. Okay, it turns out I have the function generator I need because it is the 501, and I do have a 501, so that's good. The problem is I do not have enough of the 10x attenuators, so I'm going to have to wait on shipping for that. I will do the calibration in the next video, and probably hit the calibration of the 501 and the 501A in the next video. Let me know what you guys think. Let me know what you guys want to see in the comments down below. And thanks for stopping by the lab. Anybody has any questions? Let me know.